Welcome to Tech Brothers with Amir. In this video, we are going to talk about built-in functions for data frame in PySpark. So first of all, I'm going to go ahead and show you my sample data that has name, age, and height. You see some of the values called none, that means the null values. And here's one value called NaN, and I'm converting that value to the float. So what exactly is NaN? In PySpark, NaN, not a number, represents undefined or unrepresentable numerical values, often resulting from operations like dividing by zero. Unlike null, which signifies the absence of the value, NaN is a specific floating point value indicating an invalid numerical result. PySpark treats NaN value differently from the null values. It does not consider NaN as null. To handle NaN values in the PySpark, one can use function like isNaN to identify a row containing NaN value, or can use fill NA or na.fill to replace NaN values with specified values such as 0, or maybe you want to use any other values, or drop NA to remove rows containing them. So that's the way you will be able to handle NaN values. And how the NaN values will get created when they are sometime we divide a number with the 0. So those type of the outcome create those NaN values. So here is a data frame I'm creating called df DataFrame spark.create data frame people data. We are using this sample data. Then we are providing the list of the column name, age, and height. Then I'm going to go ahead and execute this. What it is going to do, it is going to create us this df data frame and then show us the records. So let's take a look on this data frame here, and you can see right there we have name, age, and height. You see that Amir and Sarah. Then we have null values, then we have age, null value, and then again age, and here is the null, and then you have a actual value, and then you have NaN value. Okay, great. So now we go to different functions and take a look. So in this case, if we want to select two columns, let's say name and age from the data frame, so we will have use select function here. So df.select, then we say column. So and then we are saying this column name, and then again a column age. So we are selecting, and then saying show. If I run this one, it's going to select two columns from my data frame. My data frame has name, age, and height, but as I'm using select here, I can specify the number of columns that I would like to see. And here you can see that name and age is displayed here for this result. See right there. So df.select, and then provide a list of the column that you would like to see. Now let's go to the another function called lit, and then that is used with the literal constant value. So if you want to create a column with some constant value, you can use lit. So here is my data frame, and then df.select, and I said lit 100 alias literal column, lit static text dot show. If I will run this one, is going to add two columns, and those are the constant or static columns that we have right there. So you can see right there. Okay, now I did not select other columns. I could have selected other columns as well with this. So let's say if I would like to select a column name as well, I could just simply do that, just putting in this list. So now I'm selecting name, then also adding two more columns to the output. So let's execute, and you can see that now I'm displaying Amir. That's name and first literal column, and second static column or literal column. So those are just static values or constant values. Now let's go ahead and take a look on the broadcast function. So broadcast function marks a data frame as a small enough to broadcast across all the worker nodes. This is very helpful if you have like dimension table and you want to broadcast across all the nodes, and then that can be joined with other data frames, especially for the fact table data and those partitions, and then give you results faster. So in this case, you can broadcast your data frame. So here's my df for small. That's a new data frame I'm creating here, spark.create data frame, and here's the result. So Amir developer, that's the first record. Then we have Sarah analyst, and then these are two column, name and role. So these are this is my sample data. I'm going to go ahead and create the data frame called df small. Then I'm saying df for broadcast equal to broadcast df small. So I'm broadcasting a df small, and that's my data frame name. Now in the next one, you see that I'm using df for that, the data frame. We have very first data frame with sample data. I'm joining with the df broadcast right there, and then I'm joining on the condition df dot name, the name of the first data frame, equal to the df dot broadcast, then a name. So and I'm doing the left join on these two data frames, and then I'm showing the result. So you can use the broadcast function here to broadcast your data frame, and that will mark this as a small data frame, and then broadcast across all the executor nodes. So here's the name, age, and height that came from the first data frame, and then we have name and role that's coming from the second data frame, and then it is joined on the name. So that's why we have Amir and Amir, we have Sarah and Sarah, and then null is equal to value null coming as well. Okay, now right here what we have coalesce. So in case if you want to return the first non-null value among the specified columns. So here I'm saying df dot select. So we are selecting a list of columns, and I'm saying coalesce, and then I'm providing first column. So then providing second column, and then I'm saying lit 0 alias as first non-null. Then that's the name I'm giving, and then I'm saying dot show. So what's going to happen? Let's say age has the value, so it's going to show us. If age does not have the value, then it's going to check the height column. If that has value, then it's going to show us. If the both of them doesn't have the value, then we are adding a constant value here, 0. So that's what's going to happen. So first non-null value will be returned from those columns. So in this case, if we see that the 34, that was a first that's the age coming from my first record. Then we have here is height, and then we have 28. So if you will see my original data frame right there, you see that. So this is we are using these three columns, right? So age was first non-null, and sorry, this went all the way here. Age was first non-null, and then we have height non-null in these three columns, and then we had age again in non-null. So I use these three column check, and two columns, sorry, not three. Okay, so I was checking two columns, and that's why let me see right there, yeah, age and height, and any of the non-null values will show up first, whatever. If not, I mean, then you have come as a 0, as I am at the third column here. Now is nan column checks if a column has a nan value, and nan value only for the float and double types, and is null checks if the column has null values, work for all data types. So here I'm saying df dot select is nan, check in the height if the height has any nan value, and we see that there was one value, that was a nan value in the height. Then I'm checking is null for the name column, and saying is null in if there is any value in the name column is null. So if I run this one, I know there is a one value in the name column, and there is one value in the first column. What was that? Name and age, sorry, height. So there are one value. So you see right there is null, yes, there is a true value, there was one value, and then we have is nan is also true, there was one value. I think it would be better if I will just say this one. So if I will just simply take height and age, and what I'm doing here is nan, so I'm going to go ahead and actually use the height here, so you can see the value itself. And also I can put name. Okay, so you guys can kind of visualize this whole thing. Okay, so that will do it. Now if I will execute, at least you have visual like where exactly is the null value, and if they're showing it correctly or not. So we have actual height value right there. So you see that height null is yeah, so we are checking is nan. So you see that wherever it is nan, it is saying yes, it is true, and then wherever the name is null, so it is true. So that's why you can use is nan to check if there is a null value. It's going to return either false or true depending on the if it is value is present or not. Now if we want to create a monotonically increase ID, generate a unique ID 64-bit integer for each row, we can do that, and the function is called the monotonically increasing ID, and that's what you will use. So here I'm using data frame, my data df with column, adding a new column, and that column is going to be unique ID, and then this is the function I'm using. So I'm going to go ahead and execute, and you will see I have the whole data frame and then extra column added to it. So I have name, age, and height, and then I have unique ID. So right there you can see there. Okay, now here if you want to struct, that will do combine multiple columns into a single struct nested column. So we have also studied that how that works, but you can watch my older videos. Here I'm saying data frame dot select, and then I'm saying struct, and here I will provide the list of those columns. Here column name alias as person name, and then I'm saying column age alias as person age alias then person, and then show. So if I will go ahead and execute this one, what's going to happen is going to create a struct type for me by using those columns, and you can see right there it created that struct type for me. We have Amir and the age, so see right there Sarah and null value, and then we have null and 38. So it put those two columns together in a struct, so in the as a struct field. So you can call this as field 1 and this is your field 2. So that's what it is. Now if we have a nan val that returns the column 1 if it is not nan, otherwise return column 2. So you can use nan val and checks this column against this column, and it's going to return you it returns column 1 if it is not nan. So let's say this one is not nan, it's going to return that value, otherwise it's going to go for second column. So we can execute this one as well, and here is our output. You can see right there. So it return null 1. This is not the value. We have actual value in data frame, and then 28 is also age. So we use 2 column height and age, and depending upon those values inside that data frame, that's what we are getting. Now if you want to create random seed, it generates a random float between 1 and 0 uniform distribution, then you can use this one. Then you can use random n, generates a random float from a standard normal distribution. So you can use these functions to create random numbers here. So you can say random, and that's very simple, alias as uniform, and random n alias as a normal. So that's in case you need to create those random values between the decimal 0 and 1. So you can see right there it create those values for you. Now we have Spark partition ID, return the partition ID of each row. So if we are saying data frame with column partition ID, and then what we are doing here, we are saying Spark partition ID and then dot show. So it's going to create add the partition ID for each of the row. So let's execute this one, and it's going to return us the partition ID against our each of the row data frame row. So here is you can see that this is the partition 1, partition 2, and partition 3. So depending upon sometime you have less partition, sometime you have more partition, but you can see how many rows are in each partition by using a Spark distribution ID, Spark partition ID, sorry. Okay, now here you will see when, and we will use for conditional logic similar to the case statement in SQL. So here we have our data frame, and we say select, and here I'm checking when a column age is greater than 30, then you say above 30, okay, and then otherwise 30 or below, alias as the age group. So this is a kind of case when, and you know, that's where it is you use in SQL most of the time. You check the condition, if it is true, then use the first as a static value, otherwise use the second one to create your new column. So here is age group, and above 30, 30 or below, 30 or below. So you can know how to use a when or a case statement here, you know. Okay, bitwise underscore not column perform bitwise not operation on an integer column. So you can take a look on that one. So here is a bitwise underscore not, then put the column on which you would like to perform that operation, and this is gonna be just normal, depend upon your data inside that. So you can see right there. So okay, so it is giving you bitwise not output. Okay, here you have expression, then parse a SQL expression string and return it as a column. So We can use expressions here, like in case we need to write some expression like SQL expression, we can use expr and then write our SQL expression, and that will work exactly like SQL. When we write age plus 5, that's going to be add 5 added to the age column, and then it is going to return us age plus 5 as the alias name. So if you, that's a very simple way to write your kind of SQL expressions and then get the column out of it. So DataFrame dot select expression, and then right here inside the expression, and then you want to see those records, we can go ahead and execute, and it's going to return us the records. So you see that wherever the value was present, it is added. Now our last we can greatest and the least, the returns the greatest value among the specified column, skipping a null, and then we have the least, return the least value among the specified column. So we can use a df dot select, and here we can use greatest, and we say age, height. So and then it's gonna compare the values for two columns and give us the greatest, and the alias as max value. Then we use least, age and height, then we say min value. If I will execute this one, it's gonna get the max value, whatever is the max. So here's a 34 in the age, and the min value was 38 for as well. Then you have height 165, and then you have nan here, and min value is the 28. So undefined value, that is the larger, we don't know what exactly is that value, so it took as this one. So you can use the greatest for the columns, return the greatest value among the specified columns, skipping nulls, and or you can use the least and returns the least value among the specified columns, skipping nulls, and you can use multiple columns here. So I use these two columns. I thank you very much for watching this video. Please subscribe my channel, and I will see you guys in next video.